Hello, this video is on section 7.5, which is titled Exponential and Logarithmic Equations. And learning target for today is to solve exponential and logarithmic equations. We're going to be taking a look at quite a bit of examples and a bunch of different ways on how you can solve them, but you're looking for a variable and trying to get it by itself, so let's go ahead and get started. The first one is 16 raised to the 3x equals 8. And the only way we can get our x by itself is by converting it from exponential form into logarithm. So remember, we always say that logarithms equal exponents. So we have our logarithm equal to our exponent, and the base of our logarithm is the base of our exponent, and we are taking the log of that number. So now, by change of base formula, we take the log of 8 divided by the log of 16 in order to calculate it in the calculators, and it's equal to 3x. Log of 8 divided by log of 16, and that's going to give us the fraction 3 over 4 is equal to 3x. And then getting our x by itself, dividing this by 3, and as a fraction it is 1 over 4. Alright, so converting it from exponential into logarithmic form allows us to manipulate our x a bit easier. One more example is if we have 27 raised to the 3x equals 81. Again, converting it to logarithms equaling exponents. The base of my logarithm is the base of my exponent, and we're taking the logarithm of what that number is equal to. Change of base formula, log of 81 divided by log of 27 equals 3x. And as a fraction, that is 4 over 3 equals 3x. And dividing this number by 3, we get the answer to be 4 over 9. It's much easier if you keep all of these in fractions instead of writing the repeating decimals of 0.444 or 1.3 repeating. And a way you can check is by plugging these into your original equation. So we have 16 raised to 3 times 1 divided by 4, and this should give us the answer of 8, and it does, so we know that it works. Alright, another way we can solve problems that look like this is, instead of converting it into logarithmic form, we can actually take the logarithm of both sides and use our power property by bringing the exponent down in front. So if you take the log of both sides, you actually create an exponent that can be brought in front of your logarithm. 3x times log of 15 is equal to log of 285. And then by dividing both sides by the log of 15, these cancel out, and we have 3x equals log 285 divided by log of 15. And I'm going to see if I can make this a fraction. Nope, so I'm going to round this decimal to the nearest hundredth. It's going to be 2.09, and divide everything by 3. It's going to give me an answer of approximately 0.70, rounding it to the nearest hundredth. Alright, so again, you could have converted this into logarithmic form, but you also can take the log of both sides and use the properties that we talked about in the last section by bringing your power out in front and multiplying it by the logarithm. Taking a look at the exact same type of problem, take the log of both sides, bring your exponent down in front. Now this is the log of 130. Log 130. times the log of 5 equals log of 130. Then dividing both sides by your log of 5. That will give us log 130 divided by log of 5. And we get 3.02 approximately. 3.02. And dividing both sides by 2, we get x equals 1.51. Alright? Now, looking at the same types of problems, but instead of setting it up originally in exponential form, you may have one that is set up into a logarithm form. And one way you can solve it, that we're going to go over first, is by converting it from logarithmic form into exponential form. So our base, our logarithms equal our exponents. So since our base here is 10, that means the base of our exponent is going to be 10. Our exponent is what the logarithm equals, which is 2, and this is equal to the number inside the parentheses. Converting it from logarithmic form into exponential. 10 squared is equal to 100. Adding 3 to both sides gives me 103 equal to 4x. And then dividing 103 by 4 as a fraction is just 103 over 4. You don't even have to write decimal form. Can't be reduced at all. So this is your answer. If you take and plug it back into your equation, the log of 4 times 103 divided by 4 minus 3, you should get an answer of 2. And we do, so we know how that works. Same exact thing over here. We have a base 10. So your base of your exponent equals inside the parentheses. 10 to the negative 1 power is the same thing as 1 over 10. And then subtracting 3 on both sides is going to be equal to negative 29 over 10. And then dividing this by negative 2 is going to multiply the bottom by 2 to get 20. So negative 29 over 20 is equal to x. Okay, this can all be done in the calculator. You can take 10 raised to the negative 1 power, and you get 0.1, which is also 1/10. And then by subtracting 3, you get negative 0.29, but as a fraction is negative 29 over 10. And then dividing it by negative 2. As a decimal is 1.45, is a positive 29 over 20, not a negative. Okay, so that's converting from logarithmic form into exponential form. Another way we can do this is if we have a problem that is separating two different logarithms, where one is x minus 3 and one is x, and that is equal to 1. You can rewrite this as one logarithm by combining these two together, and since it is plus, you multiply everything that is on the inside. So multiplying this out, we get log of x squared minus 3x equals to 1. And then we can convert this to exponential form since this is my base. I have 10 to the 1 equals x squared minus 3x. Subtract 10 on both sides to create a quadratic equation. And I think by factoring two numbers that multiply to equal negative 10 but add to equal negative 3 are negative 5 and positive 2. So x minus 5 is equal to 0 and x plus 2 equals 0. So that means my answers are x equals 5 and x equals negative 2. Checking for the solutions when you plug it back in. you take the log of 5 minus 3 plus the log of 5, we should get 1, and we do, so that one works. Then trying negative 2, log of negative 2 minus 3 plus log of negative 2, we get a non-real answer. So this is no solution. This is not a solution. The only one is x equals 5. This is actually an extraneous solution. It's extraneous because you cannot take the logarithm of any negative number. And when you do it right here, you get logarithm of negative 2. When you do it here, it's logarithm of negative 5. And that gives you a no solution. Looking back down here at the bottom, these can be combined by division since it's a minus. So the log of 6 divided by 3x equals negative 2. Converting it to exponential, my base is 10 equal to my exponent of the number inside the logarithm. This is the same thing as 1 over 100 is equal to 6 over 3x. And you can actually solve this by cross multiplying. You have a ratio equal to another one, or a proportion. So 3x times 1 is 3x, and 100 times 6 is 600. Dividing both sides by 3, you get x equals 200. And let's check and see if this solution works. We should get log of 6 minus log of 3 times 200, and we should get negative 2. That works, so it's good. Alright, so solving logarithmic and exponential equations, in most cases, is going to have you convert from one form to the other. If you see a log, you're going to want to convert it to exponential. If you see an exponential equation, like these two up top here, you're going to want to convert it into logarithm and use your x's a lot more effectively to get them by themselves. Okay, thank you.